I'm going to throw some tricks at you. Let's see how smart you are. Here we go. Ready? Even degree. So that's got to be a U shape. Okay, that's fine. Okay, that's just a single, so there's no multiplicity there, so it's just going to cut. This one's going to be some sort of S shape, right? Yeah, but look at the way it's written. It's written as 3 minus x. Huh? Well, that, if you write it properly, is minus x plus 3. We don't like that. We don't like that at all. And since this is a cube, that negative will come into play. If it was a square, for example, we factored out a negative, who cares? That negative squared, negative times a negative, is a positive, wouldn't matter. But being that this is an odd multiplicity, a negative times a negative is a positive times a negative is a negative, so that negative does come into play. So we can actually factor out the negative on this, making it x minus 3 cubed. Aha! Guess what? Bing! That negative has to go up front. So now we have a leading coefficient that is negative. Is that not cool or what? Check this out. Multiplicity 2, right? Plus a multiplicity of 1 from this guy, plus a multiplicity of 3. So look what I've got. I've got degree 6. So that means I can have potentially up to 6 intercepts. Yikes. Okay, so let's figure out what those wonderful zeros are. Well, from this guy, obviously a minus 2. From this guy, obviously a minus 5. And from this guy, obviously, well, no, not obviously, because we factored it first, and we found out that this is going to actually have an intercept of plus 3. And there's going to be, 3 there, 2 there. Oh, boy, I'm getting dizzy from all of this. Okay, let's just write it down. Let's see what we got. Minus 5. 1, 2, 3, 4, 5. So I got it an intersect there. I've got a minus 2, an intersect here. And I've got a 1, 2, 3. I've got an intersect there. Think about this. This is negative. Also, being that this is, oh, look at that. It's an even multiplicity. That means negative means down. Even, that means they both have to be down. So I'm predicting something here. This is going to be kind of interesting to see. I'm predicting that this guy's going to come up here. Now, this is the 5, so it's going to cut through. Okay, this is the minus 2, so it's going to have a bendy here. It's going to bend like this, okay, and around. Perfect. I think the intercept is going to be way out here somewhere. Then it's going to come down here and do my S shape down here and then conclude. And look at that. They all match up. That's my prediction. Let's actually throw this in the calculator and let's see what it actually looks like. I'm also curious, before I graph this in the calculator, I'm kind of curious as to what that's going to be. How do I figure that out? Remember, x equals to 0 for the y-intercept. So that's going to be 2 squared, okay? That's going to be times 5, right? That's going to be, 3 cubed. Oh my gotcha. 2 squared is 4 times 5 times 3 cubed is 27. That's going to be a huge number. That's going to be 20 times 27. Well, okay, wait a second. 2 times 27 is 54 with an x. That's going to be what? That's going to be 540. That's going to be the y-intercept. That's my prediction as to y-intercept. Oh my God, that's going to be huge. Okay, so let's write the window settings for this once we graph this. I'm going to just throw it in my graphing calculator right now. So there it is. Oh my God, look at that. So I was a little bit off on my prediction. My bumps were a little bit out. So I'm going to go back to my graph here and I'm going to say, okay, this one should have been way up here. That one's about here, and then there's my S curve. But what I want to show you is that, yes, I did have my parabolic shape there. I did have my S shape there. Okay, so let's prove that again. There it is, just as I predicted. There's my parabolic shape. There's my S shape. But check out my window settings. Remember, this was at 540. If you don't believe me, let's go out and figure it out. Second calc, let's find the value at x equals 0, and look at that, 540 as predicted. So if that's 540, what could this possibly be? Holy smokes, that's going to be like huge. So let's find out the local maximum. Second calc, let's find the maximum, which of course is 4, and let's mouse. Oh my goodness, we're going to be mousing all day long. Look at this, going right up here. Da, 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 da. There's my left bound. There's my right bound. Oh my goodness, guess, and look at that. I'm at 1,447. Oh my goodness. So you can tell that I put out here at probably plus 1,500, minus 1,500 for a window setting. Oh, and still only at 1010. Holy smokes. What an incredible thing here. Okay, so I'm still at minus 10, positive 10, going up by ones. Now for the Y window settings, I'm at minus 1,500, positive 1,500, and 1. How did I find that? Lots of playing around. I had to play around to figure out what those things are going to be. Okay, let's talk about our multiplicities now. The zeros, minus 2, minus 5, and 3. Remember the multiplicities for them. Minus 5 only cut once. Minus 2 cut twice. And positive 3, sure enough, cut 3 times. Aha, isn't that interesting? So there's our U shape. There's our S shape. Okay? And of course, this is just going to cut through. Oh, look at that. 3 times in a row. I spelt it right. Okay. So, kind of cool. Let's keep on going. Oh, ho, 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 ho. Degree of the polynomial, just add up the multiplicities, and hopefully it works. This is going to be a degree of 6, multiplicity of 6. Using technology, we can find the minimum. Well, we found the maximum this time, and we found out the y-intercept was 540 using technology. Wow, what a neat question. The thing you have to watch out for, though, was when you got something that looked as weird as this. And remember, like I said, that only matters when the multiplicity is odd. Don't forget that you had to factor out the negative first. That's what allowed us to predict that this was going down and down. Okay? So make sure you look for things like that.